this video, we are going to be going over Gaussian elimination. We're going to talk about what it is, what it's used for, and then have one giant example step by step. Alright, so the purpose of Gaussian elimination is to transform an augmented matrix, or any matrix, into row echelon form. Now, row echelon form, there are three rules to it. The first rule is that the first non-zero in each row is the leading entry, and it is 1. What that means is the first non-zero, so here, first non-zero is 1, it has to be 1, and we call it the leading entry. Now for the second row, the first non-zero number also has to be 1, and this is the leading entry of this row. Third row, first non-zero entry has to be 1. Now the second point is that each leading entry is in a column to the right of the leading entry in the previous row. So this leading entry is to the left of this leading entry, and this one is to the left of this one. The last point is that rows of all zeros are below rows having a non-zero number. In this case, we don't have any. But if there was an entire row of zeros, it would be at the bottom. This might not be super clear yet, but we are going to go over an example. So, first thing is we have our sets of linear equations. This is x plus 2y plus 3z is equal to 9, 2x minus y plus 7 is equal to 8, 3x minus 7 is equal to 3. So the question that you would be asked is solve for x, y, and z. The first thing you need to do is you need to write it in a matrix. Because we have our answers here, it needs to be in an augmented matrix. Hopefully you already know how to do this. If not, my last video explains it. But we're going to write it out like this. So we have 1, 2, 3, 9. This is row 1. 2, negative 1, 1, 8. Row 2. 3, 0, negative 1, 3 for row 3. Now we take this, and the first thing we are going to do is we are going to look for the first leading one. Now that's in row 1, and it's right there. It's already a 1, so the work is done for us. Second row, it has to be to the right, so it cannot be here, and that means that this 2 has to be a 0, and this negative 1 is going to be a 1. We are going to go step by step though. Let's start with the 2. We're just going to make it a 0. How do we do that? We use our row equations. Again, last video goes over this. So the new row 2 is the old row 2 minus 2 times row 1. The reason we did that is because we want 2 to become a 0. 2 minus 2 is 0, right? So 2 minus 2 times 1 is 0. But because we did it to this number, we have to do it to the entire row. All right? So I did that to this entire row. Here we have negative 1 minus 2 times 2, so negative 1 minus 4, which is negative 5. And then we have 1 minus 3 times 2, which is 6, also negative 5. And we have 8 minus 2 times 9, which is 18, and that's negative 10. We write it out. Rows 1 and row 3 have not changed. The next thing we want to do is we want to get our next leading 1. If I wanted to, I could keep going and make this a 0, but we're going to go over that in the next video with Gauss-Jordan elimination anyways. So how do we make a negative 5 turn into a 1? Well, we divide it by negative 5. Instead of dividing it here, we're just going to write multiplied by negative 1 over 5. Same thing, it's just the nicer notation for this. So our new row 2 is going to be negative 1 over 5 times the old R2. 0 times anything is still 0. Negative 5 times negative 1 over 5 is 1. Same thing here is a 1. Negative 10 times 1 over 5 is 2. We rewrite rows 1 and row 3 just as they are. So what we've done so far is we have our first leading one, we have our second leading one, and now we're going to get our third leading one. And remember, it has to be the first non-zero number, so that means this is 0, 0, and 0. We are going to make the 3 turn into 0 now. So row 3 is equal to the old row 3 minus 3 times row 1. The reason we do that is because 3 minus 3 is equal to 0. So 3 minus 3 times 1 is 0. And that's what we're going to do to the entire row. You can pause and look at this to make sure you understand. So far we have a 1 here, leading 1, and we want this to become the next leading 1. That means this is going to have to be a 0. So we have our old matrix, and we want this to become a 0. So the old row 3 plus 6 times the old row 2 is equal to our new row 3. What this means is that minus 6 plus 6 is equal to 0, and that's what we wanted to do. I'm going to rewrite it out, and so our last step is to put this and make it a 1. We're going to do that. -4, we want it to be a 1, right? So we are going to multiply it by -1 over 4. We do that to the entire row. This is our row echelon form matrix. Echelon, in French, échelle, it's like a ladder. That's how you can think of it. It's like you're going up right here. That's the way I remember it. Now, what do we do with these? What was the purpose of doing Gaussian elimination? Because that's how we got our row echelon form. Well, how about we take our rows and rewrite them into equations? So if we remember, this column is x, this is a y, and this is a z. So let's rewrite row 3. 0x plus 0y plus z is equal to 3. So we know that z is equal to 3. Let's rewrite our second row. 0x plus y plus z is equal to 2. Well, we already know what z is, right? So let's just put that in this equation, and then we have y plus 3 is equal to 2. So we already figured out what z is, and we already figured out what y is. Our last equation is x plus 2y plus 3z is equal to 9. We already know what z is, we already know what y is, so we're just solving for the one variable, which is x. You can just use our basic algebra, so x plus 2 times -1 plus 3 times 3 is equal to 9. X is equal to 2. So as with anything, it's really important that you practice. For this one, you can draw a line here and solve for x, y, and z. For this one, you draw a line here and you solve for x and y. But for this one, we have an a. Now I want you to pretend it's the exact same thing, and the a is just a variable, and we are just going to try our best and see what you can do and what you can't do with this. Alright? Next video is going to be about Gauss-Jordan elimination, and what this is going to help us with is solving everything in one step. So instead of taking our matrix and putting it back into equations, we won't even have to do that.